America, we can get an insight into how the Earth might have got its tilt. This is the Barringer crater in Arizona. 50,000 years ago, a meteorite struck this site, and just look at what it's left behind, this enormous hole in the ground. This impact would have thrown debris out over tens of thousands of square kilometres. And all the rock around here, like this, is what's left after that explosive event. This enormous crater is like a lesson in how size isn't everything, because the crater itself is 1 kilometre across, but the thing that caused it was only 50 metres in diameter, which is really quite small. And the reason that such a small thing could cause such a big hole is because it was travelling so fast. Impacts like these are extremely rare, but in the Earth's past they were far more common and a lot bigger. Around 4.5 billion years ago, the solar system was still in the process of formation. The Earth was just one of many protoplanets that orbited the Sun. Amongst these protoplanets was a small Mars-sized planet that's been named Theia. Its orbit put it on a collision course with the Earth. Theia smashed into the larger Earth and was obliterated. The impact very nearly destroyed our planet too. The collision knocked the planet over, tilting the Earth's axis of rotation. This tilted Earth might still be oscillating madly, were it not for another consequence of Theia's impact. A huge amount of debris was blasted into space. Gradually, this debris coalesced, captured by the Earth's gravity, and it formed the Moon. Billions of years later, the gravity of the Sun and Moon together act as a sort of counterweight, stabilising our tilt. It's extraordinary to think that the Moon is both evidence of what caused Earth's 23-degree tilt and the celestial object that helped maintain it. But the stabilisation the Moon provides isn't perfect. And the smallest variations in the angle of tilt can have profound consequences.
Although the gravitational pull of the Moon and Sun together have stabilised our tilt, they don't do it perfectly. Today, the angle of tilt is 23.4 degrees, but over regular 41,000-year cycles, the angle swings between 22 and 24.5 degrees. Back when the Sahara was green, the Earth's tilt was close to its maximum angle. Together with small cyclical changes in the direction of the tilt and the shape of our orbit, the result was the Sun shone more intensely over the northern hemisphere, powering a monsoon in the Sahara. About 5,000 years ago, the monsoons failed here, and very quickly the vegetation started to disappear. Within a few hundred years or so, this area had gone from savanna to desert. And the people who settled this once verdant land were forced to move north and east to a still fertile river valley, the Nile. It's rather wonderful to think that because the changes in our tilt and orbit are cyclical, there may come a day when the Sahara will be green once again. But not for another 15,000 years. Since we began our journey at the spring equinox in March, the days have grown longer in the northern hemisphere, and the sun has arced higher in the sky. That process reaches its climax on June the 21st, the summer solstice. Wherever you are north of the equator, on the solstice, you'll experience the longest day of the year. And there are few more significant places to be for the solstice than one particular place here in Egypt. I've left the desert and travelled to the temple of Kom Ombo, near the ancient city of Aswan on the Nile. I've come in search of a famous shaft of solstice light. The Earth's tilt reveals itself every time we step out into the sun, and we can see it in the shadows that it casts. The most revealing of all are those cast by the noonday sun. In the temple precinct, there's a 2,000-year-old water well. It's also a perfect light well, and that becomes obvious on the day of the solstice. Here at the bottom of the well, my shadow is directly beneath me, and there's no shadow at all being cast by the walls of the well. It's midday on the summer solstice, and the sun is directly overhead. The solstice marks the day on which the Earth's tilt has its strongest impact on the northern hemisphere, which is leaning to its maximum extent towards the sun. It's revealed in this way here in Aswan because I'm standing on a very particular point on the Earth's surface. If we were to trace a line from Aswan right around the globe, we'd be marking a line of latitude, but also the furthest point north at which the midday sun is directly overhead. This is the Tropic of Cancer. And because the Earth is tilted at 23.4 degrees from the vertical, the Tropic of Cancer is 23.4 degrees above the equator. The June solstice also defines another significant line of latitude. As the northern hemisphere points towards the sun, the Arctic experiences 24 hours of daylight. On the solstice, the midnight sun reaches its maximum extent, a line marked by the Arctic Circle, which is 23.5 degrees from the North Pole. Isn't it astonishing that the Earth's tilt has such a dramatic impact? It's that tilt that drives our seasons and powers our weather. It's had a profound influence on our human history, and even today it dictates how and where we live on this extraordinary, unique planet of ours.